Assalamualaikum and hi. We are from Group 5. We present about seismic well tie and seismic inversion. Our group consists of myself, Amina Shazwani binti Saiful Bahri, and my other two friends, Ainur Zulaika binti Zainuri and Kisina Uzma binti Azli. So this will be the content for our presentation. First, we will start with introduction and objectives, followed by theory, workflow and results. And after that, each of the member will tell about their experience learning Rock software. And lastly, conclusion. Now I will explain the introduction of Rock software, which is the software that we use for our lab work. RockDoc is a comprehensive portfolio of rock physics, geopressure, geological modeling software, and geomechanics solutions for accelerating and improving subsurface predictions over asset lifetime. It adds geomechanical model building to rock physics and quantitative interpretation. These are the objectives of RockDoc. Firstly, it acts as rock physics infused reservoir characterization. We can leverage the knowledge from well-based rock physics analysis. Secondly, we can capture and analyze both data and geological uncertainty in the estimates. Second objective is powerful and interactive seismic data conditioning and inversion. We can get access to fast recipe-based seismic data conditioning and seismic inversion workflow. Any parameter in the workflow can be adjusted from data conditioning to inversion to phases classification. Lastly, the objective is it has integrated rock physics driven 4D analysis. We will be able to get a full understanding of the impact of production on seismic response. The software provides a framework for modeling the effects of production.
Okay, hi, my name is Ain. Now I'll be talking about the seismic well tie. We will explain on the theory, the workflow and the results of the seismic well tie based on our lab work on Norton 2. So for the theory of the seismic well tie, well to seismic tie is a fundamental steps in seismic interpretation. It relates subsurface measurement obtained at a well bore measured in the depth and the seismic data measured in the time. A time-depth relationship is typically computed by integrating the slowness function measured at the well bore. We will tie the well to the seismic, and next is we will estimate the deterministic wavelet, and we will QC the wavelet extraction location and the quality, and then the wavelet will be saved and the result will be displayed. Okay, next, after following all the steps I mentioned in the workflow, this is the result that we will obtain. We can see that the seismic section are synchronized with the wavelet. For example, the blue color in the seismic will match the blue color of the wavelet. So this is to prove our seismic is tight.
Hi, I'm Christina. So now moving on to the next chapter, which is the seismic inversion. So in this chapter, we will discuss more regarding the theory of the seismic inversion, the workflow during the seismic inversion of the lab work, and then the results of the seismic inversion. So this is the theory of the seismic inversion. Seismic inversion is the original reflectivity data which is changed from an interface property to a rock property known as impedance, which is calculated by multiplying sonic velocity by bulk density. In an inverted data set, the amplitude are describing the internal rock properties such as the lithology type, porosity, or the fluid type in the rock. Inverted data is ideal for stratigraphy interpretation and reservoir characterization. So in general, because of its efficiency and quality, most oil and gas companies now use the seismic inversion to increase the resolution and reliability of the data and to improve the estimation of the rock properties, including the porosity and net pay. Therefore, compared to working with the seismic amplitude, inversion results show higher accuracy and resolution of the interpretation. So it can be said that the principal objective of the seismic inversion is to transform the seismic reflection data into a quantitative rock property and descriptive of the reservoir. So this is the workflow of the seismic inversion. So the first step, we will load the well into the window, and then we convert to the well to the seismic tie. Then we check the seismic data condition. After that, we do the wavelet estimation. After the wavelet estimation, we will convert the well to the seismic tie. Then we will proceed to the seismic inversion. Then we will do the inversion analysis to check the accuracy. After that, we will do the general attributes to get the accurate inversion. In this slide, we will discuss about the result of our lab work for the seismic inversion. So as seen in the figure, which is in the slide, this is the result for the seismic inversion of the synthetic simultaneous inversion. The simultaneous inversion is basically equal to the conversion of the seismic data to elastic layer properties through inversion of multiple partial angle of offset stacks. So by combining the P and also S impedance, it will provide an excellent lithology and also fluid indicators. So by separating the shale from the sand, the effective porosity can be derived more accurately. So in addition, we can see in the figure that we have zoomed in, it gives a higher resolution, a clearer image, and better match with the well of the Norton 2. So I will pass this presentation to Amira Shazwani for the conclusion.
So the conclusion for our lab work, firstly, the software's ability to characterize the reservoir and analyze the well log is essential for any potential reservoir interpretation. Secondly, a fundamental study of QI and rock physics can help to better comprehend how rock dot works. And thirdly, the knowledge of rock dot could be implemented when entering the geophysics industry.
So during the traffic of learning the rock dot software, we gain some experience that we think that we will not get it in other universities. So the experience that I can share on behalf of myself. So the first one is that I learned a new software which is the name of rock dot. I never heard about the software before, but the GAs are really helpful and passionate in teaching us. So the second one is I know the purpose of the rock dot software because we know that predicting and understanding the properties of the rocks, pressures, and the fluids are the key for a successful exploration and production project. So the third one, sometimes I'm having a blurry vision because of looking at the computer for too long. However, it's in a good way because the GA are conducting the lab session in a fun and interactive way. So nevertheless, what I say in general is that these lab sessions is a preparation for us as the geophysicists in the future to familiar with the rock dot software.
So for my experience, I am very excited to learn rock dot software that is frequently used in geophysics industry. And thanks to our lab GAs, Mr. Basil, Mr. Faris, and Mr. Rafael, I am able to apply what I have learned in the class, in the theory class with Sir Maman during the lab session. And at first, I found a bit difficult to learn the software because there are a lot of steps involved, and I have no basic knowledge of the software. But overall, I feel like the lab session significantly has improved my knowledge and experience.
So for my experience in learning QI and rock physics lab, I think that the joy in learning the rock dot software. I have learned a lot about rock physics in the software, and I am grateful that I have the opportunity to learn this software because somehow in the future we will be using this software if we pursue our career in geophysics. The learning process actually seems a bit difficult, but I found the joy throughout the end. And then finally, I wanted to thank our lab GAs and our lecturer, which is Sir Maman, for providing us with the experience that we couldn't get anywhere else. Thank you.
Thank you, sir. So that's all from us. Thank you.